Now next topic is equipotential surface. What is equipotential surface? That I already explained in the previous video, that there is a relation between E and V, that is E is equals to minus dV by dr, that electric field is negative gradient of potential, and it's also with cos theta E dV. So a region where electric field is 0, in that case dV by dr equals to 0, and derivative of a thing is 0, then this term is always constant. So equipotential surface are those a surface at every point of which potential due to charge distribution is same is called equipotential. What is name? Equi equi means same potential. Same potential surface means the surface at every point potential is same, that surface is called equipotential surface. So this is the definition of equipotential surface first of all. Next, there are properties of equipotential surface. What is the first property? First property is no work is done in moving a test charge from one point to another on equipotential surface. How is it possible? Suppose this surface is equipotential. At this potential, potential is V. At this potential, potential is V. Let this point be A, this point be B. At this potential, potential be VA. This potential, potential be VB. Work done is what? Potential difference. Charge is taken from point A to B. Then it's VB minus VA. But potential at VB is V. Potential at VA is V. So V minus V is 0. So a surface where at every point potential is same, work done is always equals to 0. This is the first property, work done is always equals to 0 for a surface which is equipotential. Second case, second property, the electric field is always perpendicular to the element of the equipotential surface. Why so? Work done has other formula of E dot dl. E dot dl means E dl cos of theta with integration. As work done on equipotential surface is 0, means this cos theta is also equals to 0. Theta is 0 for 90 degree. So means electric field always make an angle with the angle of 90 degree with equipotential surface. Third property, equipotential surface indicate region of strong and weak electric field. As electric field is defined as E is equals to minus dV by dr, or dr is equals to minus of dV by dE. So less the dr, more the E. More the dr, less the E. This point I will explain you later how. Two equipotential surface cannot intersect each other because tangent, or because at a point on the intersection it has two value of the electric potential, which is not possible. Again at a point two value of electric potential and electric field is not possible. So two lines never intersect each other. Electric potential is a scalar quantity where potential gradient is a vector quantity. Because potential gradients have direction too, it has direction also with it. Now, this is the equipotential surface for various star distribution. How does it look like? For a surface of unit, for a positive charge, equipotential surface are concentric spherical shell. This is the shape. If this is a charge at center, for it the equipotential surface would be concentric circle around it. Concentric means with same center, concentric circle. If these concentric circles lie very close to each other, means spacing between them is very less, means their electric field is very strong. This from the previous property, that dr is equals to dv by E. If this is less, spacing is very less, means E is very strong over there. So more closely, so if more closely equipotential surface lie to each other, more is electric field. If they lie far from each other, means this is first circle, second circle, third circle, spacing is very much. If dr is more, then E is going to be less. E is going to be less. So, weaker is the field. Next, if we have two charges which are equal and opposite, for that equipotential surfaces look like this. Means from the center they appear to be closer, from this side they appear to be closer, and from here they appear to be far away from each other. For two opposite, for this was for two opposite, and for equal charges they will like this. Means from here they will be closely, but here they will lie far and form look like this. For uniform electric field, equipotential surface are plane, equidistance, parallel plane, perpendicular to the field lines. As we know, planes, equipotential surface are always parallel to the electric field. So, for a uniform electric field, if they are parallel to each other, field is parallel to each other, then the equipotential surface are plane, line parallel to each other. This is the equipotential surface. So more closely they lie to each other, more is the electric field. Far they lie from each other, less is the electric field over there.